Hello friends, welcome to our channel. Today I will discuss regarding on topic zero address instruction. So different address instruction I have already explained. So today I will discuss regarding on zero address instruction. In this zero address instruction, one approach I will consider, then we can understand how zero address instruction will be generated. We previously already discussed that is different address instruction like three address instruction, two address instruction, one address instruction, okay, up to that, where different operand having whenever any instruction will consider, then how many operands or variable are there, based on that they will use that they will create that address instruction. Okay, since it is a zero address, then what happens? If there is a operand, there must be a address. So zero address, how to create a zero address, how to get? Okay, that is the major question. If there is a operand used for any operation, definitely they will store in somewhere. We can access. Okay, once data is there means we can access. If there is no data means no address. If data is there means definitely it contains one address. So if zero address, how to define? One technique I will give you, that is through that approaches, without that address we can also use and operate different operations as per the instructions. That means the main concept of this zero address is using, that is stack organization. Whenever used, then there is no need of fixed address for individual data, no need. That means whenever you add or insert or delete some data from stack, obviously that data changes its position. So there is no fixed address data is there. There is no fixed data in a stack, because number of times it will change its address. So for that reason we can tell as a zero address. This is the basic concept. So a stack organized computer doesn't use an address field for the instruction, either add, multiplication or any kind of operation. Okay, we just push some data or pop some data, okay, as per the instruction. However, it need an address field to specify the operand that communicate with the stack. Okay, so what happens? Push some data, pop some data as per this instruction whenever it goes. Then what happens? There is no data address for any kind of operand whenever you go through zero address instruction. Take an example, same example you can take, that is x is equal to a plus b into c plus d. Same example we can take, and since it is it contains that is a stack organization, so what happens? You use the stack operand we can use. Okay, very simple way. If we go through stack, so use push. Okay, push a means what? Data, first data is a, we just push, and this data push into the a or particular stack, push the stack a, and TOS, top of the stack, TOS, top of the stack. This TOS is defined as a stack pointer. We can also write stack pointer, okay, as a top of a stack. This top of the stack is defined in this way. Okay, that means here top of the stack receive the data a. Here stack pointer receive the data a, or top of the stack receive the data a. Okay, similarly another data is what? Similarly b. Okay, another data is b. Then what happens? Top of the stack receive the data b. Here is d. Okay, here is a b. Then what happens? Top of the data, here top of the stack data is b, next is a, like this it is present. Then when add operation is coming, then what happens? This that add operation means we don't write any kind of data. You see, there is no data. It just push a data, b data. But when add operation is there, there is no need to write this a, b like this, because already pushed to the stack. No need to write. but operation will start like a toss top of the stack defined in this way a plus b. That means whenever operation will come or any operator and multiplication or anything or operation will start, then what happens, it just operate on last or top of two data a and b. So top of stack will be operated on a and b, okay, in this way. Similarly, same case also we can apply for c plus d. Similarly, push c, what you write, toss, write c, push d, then that is a toss d, okay, in this way, very simple way we can also write. Here similarly add, because that need to add this c and d also need to add. In that case what happens, similar case toss only receive, that is c plus d. No need to write it again c and d, because previously what happens, whenever write c d, then what happens, that will that identify its corresponding address, but there is no address here, you see, no address is required here. For that reason it is called zero address instruction. But once that operation will identify by the zero address, then what happens, it is just identify in this way. Top of the stack it identify, and the top of the stack just started that operation as per this instruction, maybe addition, maybe multiplication or any other, okay. In this way we can go through, that is a zero address, very simple. This is no operand here, but it operate, okay, that is, you see, there is no operand here, here is no operand here, but they operate. When that operation will start, then the top of the two data will be start the operation, okay. Up to here you see we can find it this way. So this particular toss gives recently c plus d, okay, and previous top that is receive a plus b, okay. Next what happens, this data I will show you how it is stored. First of all, whenever add operation is coming, you see add operation is coming, then what happens, this data it store a plus b here, top of the data, two data store a plus b. Again what happens, down here what happens, this data is a plus b data, okay. After that what happens, after this a plus b, what happens, you see a plus b, then c is coming, d is coming, here is c is coming, again d is coming, okay. Next what happens, this add, whenever the add operation will come, then what happens, again it start the operation of c plus d, here c plus d, then c plus d it will add, okay. No need to c plus c and d separately and again add, only whenever add operation will come, then c last two operand will start the operation, c and d, c plus d. So c plus d store in here. For example, here is 0, 1, 2, 3, 4, like this different address is there, 0, 1, 2, 3, 4, okay. Here a plus b, result of a plus b store in 0. Again here you see whenever add that, again a plus c plus d store in that is one position, okay, store in one position, in this way. Then 0 position a plus b, and second position, that is one position is 0 c plus d. Now a plus b, c plus d already store in stack. Then what happens, we just go through some multiplication, because last is this one already over, this one already over, next is multiplication. Then you multiply, okay. Then no need to write any kind of operand, no need. Then what happens, when you multiply, then this toss, okay, this toss what happens, this is initially it was what, this one, c plus d into a plus b, okay, that need to multiply, very simple way, okay. C plus d, last one c plus d into a plus b, both are multiply and store in that position 0. Here is a c plus d multiply with a plus b, okay, and store in 0. both multiply, store in a 0. Okay. So now this top position is a c plus d into a plus d, a plus b, and that multiplication data transfer to where x, because his total data transfer to x. So in that case what happens, that is we can write here pop. Okay, in this case what happens, write pop, because that data store is there. So pop mx, okay, pop mx, because this x contains top of the stack. Okay, because this total total available in TUS, because you see multiplication available in TUS. That total data, now you see that total data transfer to multiple, that is a memory of x, and that data need to retrieve. So pop x, the pop x we can find out and retrieve data from stack. Okay, so in this way we can use different that is address for zero address instruction. Okay, it is very easy that is address instruction, but carefully we have to take how to define different address whenever you use, that is a any kind of a variable, and when you use there is no variable. If you go through push a and b use, there is no problem. Whenever operation will start, no variable is required. For that reason it is a zero address. You see, this is a zero address. Okay, because there is no variable defined here. There is no variable defined here. Okay, you see there is no variable. Here similarly push c and d, here is what is, there is no variable. Here is it, there is no variable is here. Similarly multiplication, there is no variable is here. For that reason it is a zero address instruction. They only multiply, or they only operate as per the top of two operands. Whatever the operation is required, maybe addition, maybe subtraction, whatever the operation is required, just operate on two operand, then store in that that is top position of the stack. This is the basic concept. Okay, whenever you go through this one, then you will use this stack organization. Actually it is use stack organization. Through stack organization we can design or we can define this zero address instruction of any kind of arithmetic expression. Okay, thanks to all. I hope all of you understand this zero address instruction. It is very easy. So I explain every part, how it is designed, how to explain this zero address instruction. You can also take any other example and explain accordingly. Okay, thanks to all to watch my videos, and please subscribe my channel. I will give different solutions of different subjects. Okay, thanks to all, and please if you give any comment, you can give comments to me. Okay, thanks.